What's up guys, welcome back to the channel. Today on this video we'll be differentiating the following expression from the first principles. Right, I've already made a video where we have differentiated, in fact more than one video where we have differentiated the functions using the first principle, but this one here we have the x to the power of 5. So how are we going to do this one? So guys, if it's your first time watching a video on this channel, I would advise you guys to also watch videos on trigonometry and limits on the playlist. I already made videos there, but if you are coming back, welcome back guys. You know that we do videos in a sequence, so this is gonna be part 5 of our playlist. So this playlist that you're watching right here, it's differentiating from the first principle. So already I've done other videos, so at the end of this video you can go and click on the playlist which is gonna appear. So that playlist has video from part 1 until this one, which is part 5. So I hope you guys you will able to watch those for better understanding, because I'm gonna use some formulas here that will need you to watch the few videos that I made earlier on. All right, with that being said, now let's start. So I could say to you guys, if you have watched all the videos, I would say how about you pause this video and solve this one. Try to differentiate this problem from the first principle, and then after getting your answer, continue and let's write it and see if you're gonna get the same answer at the end of this video. All right, so what is the first step? So you need to remember, when they say differentiate from the first principle, you need to use the formula, this formula here, which is x, which is f of x prime, and then we say limit h approaches 0, and this is gonna be equaling to, let's just do this, there we go, it's gonna be f of x plus h, let me make it x there, all right, minus f of x, and then divide by h. So this is the formula that you're going to use in order for us to differentiate this function from the first principle. All right, so if you don't know how to use this formula, I'm going to try to explain it, but if you want to know into details, there is a video on the icon up there. Go and watch it. On that video, I'm explaining how to use this equation here and how to get the f of x. I'm gonna do this, but I'm not gonna go deeper on this one. So first of all, don't forget that you're given f of x. So this one here, the equation that we have here, by the way, this is f of x, so we don't have to worry about f of x because now it's given to us. Now the thing that we need to find is f of x plus h. Now with what we have, we can able to find f of x plus h. So I'm gonna do f of x plus h this side here. Hopefully I will have enough space. There we go. It doesn't look good. Let me just draw a line from here, and there we go, there we go. So this is the line. All right, so let's do it this side. Remember, f of x plus h, we just substitute x plus h where there is x. So here's what I mean. As you can see, our function here, we have -7 multiplied by x to the power 5 minus 3. So wherever there is x, we must just substitute with x plus h. So we know that this is -7, but look at this x to the power of 5. So with f of h, wherever there is x, we substitute with x plus h. But don't forget, this is to the power of 5 and then minus 3. Guys, let me just say this. Look, when you integrate from when you differentiate, sorry guys, when you differentiate from the first principle, you have to expand this problem here. Look at this, you have x plus h to the power of 5. Now this requires us to expand. Now in order for us to expand this, we need to use the binomial theorem. Now again, on the icon on top there is a video where I explain the binomial theorem, how to use the formula and how to actually substitute, the easiest way to substitute on the formula. So you can go and watch it before you continue. If you have watched it, that's great. Let's continue from here. So I usually tell people, or I usually mention that before you use the binomial theorem to expand, make sure that you write the equation. So the equation for the binomial theorem, let me just write it here very quickly. It's x plus h to the power of n, and then we expand it. So when you expand it, it's gonna be x to the power of n. This is gonna be your first term, and your second term is gonna be separated by the plus here, and then the second term is gonna be n, and then it's gonna be x, and then n minus 1 multiplied by h. There we go. That is your second term, and your third term plus. Now you're gonna have n, and then you have n minus 1, right? And then factorial here is gonna be 2 factorial, right? And then we're gonna have x, and then n to the power of minus 2 multiplied by h to the power of 2. This is the third term. Now the fourth term is gonna be n, there we go, multiplied by n minus 1, and then we have another one, n minus 2, and then the factorial here is gonna be 3 factorial, and then we know that we're gonna have x to the power of n minus 3 and h to the power of 3. Guys, I will say to you, stop at the fourth term. Remember, when you differentiate from the first principle and you find yourself whereby you have to use the binomial theorem, you don't have to do all these terms, the fifth term or the seventh term, however the term. The best way is to stop at the fourth term. If you stop at the fourth term, in fact, you get the right answer. You don't have to continue and do more terms, right? So as you can see, this is the binomial theorem. Now I would say to you, if you did watch the video on top there, I would say to you, make sure that x, you know what x is. What do you mean is here, when you extend, when you substitute x on our equation there, what is going to be our x? Obviously our x is going to be x in this case, and then our h is going to be h in this case, but our n is gonna be something else, guys. Our n is gonna be 5. Remember, n is the power, so as you can see, we have n here, we have to substitute them. And then this 5, where is it coming from? Remember guys, this 5 is coming from this here, so hence our x is x. As you can see, x is equal to x, h is h, and there we go, and our n here is 5. So I hope you can able to see what I'm trying to show you there, guys, because it's very, very important for you to write this so that you don't make no mistakes when you substitute. Now let's write this one here. So you can say f of x, you can say x plus h, right? And then you know that we have the power of 5. Remember, we took this one here. Let me just underline with the yellow color. Let me just highlight it. I don't know if it is possible. Yeah, I'm gonna highlight it here. I'm gonna highlight it here so that you can able to see it. All right. Okay. Yeah, this is good highlighting. And then let me highlight here so that you can see. I only took that one there so that you can able to understand better. So when you substitute, remember we have x to the power of n. In this case, our n is 5, so it's gonna be x to the power of 5 plus, right? When we say plus, now let's look at the second term. We have n multiplied by x to the power of n minus 5. So our n is 5 multiplied by x to the power of 5 minus 1. and then multiply by h. So our h here is h, so there's nothing that we can do there. We don't change anything. And then we go to the third term. Now the third term now is going to be n multiplied by open bracket n minus 1 close bracket divided by factorial 2 multiplied by x to the power of n minus 2 multiplied by h squared. So let's change here. So we know that our n is going to be 5, and then open bracket we have n minus 1, which is going to be 5 minus 1, and then this factorial here is going to be 2 factorial. And then we know that we have x, and then what is our n? Our n is going to be 5, so it's going to be 5 minus 2, and then our h is h, so this is going to be h squared. Now we head to the fourth term. All right, so going to the fourth term, we have n minus multiplied by open bracket n minus 1 close bracket open bracket n minus 2 close bracket, and then divide by 3 factorial, and then we have x to the power of n minus 3 and h multiplied by 3. So let's try to squeeze it in here. I hope we'll be able to squeeze it, but let's just do it. So n is going to be 5, right? That is 5. And then the first bracket here is going to be 5 minus 1, and then the second bracket is going to be 5 minus 2, and then we know this, the factorial is going to be 3 factorial. Do not forget, guys, to write the factorial. And then here we have x to the power of n minus 3, so this is going to be x to the power of 5 minus 3, and then we have h to the power of 3, because h is just h there. So this is how it's supposed to look like when we do this one. So let's continue with our x plus h to the power of 5. So when we expand, let's simplify it. So the first term obviously is going to be x to the power of 5, and then the second one here, as you can see, we have 5 multiplied there, so it's going to be 5, and then what is x? We have power of 5 minus 1, so this is going to be 4. There we go. And this is going to be multiplied by h, so we can say h there, and then we say plus. Now this one, that's where you need to use a calculator. So if you have a calculator, grab your calculator and type this or insert the following here. You can say 5, and then you say open bracket and say 5 minus 1, and then you divide by factorial, let's say 2, and then factorial. So how do you get 2 factorial here? It basically is just how do you get this factorial? Basically just click shift, then you click the button with the x to the power of minus 1, and then you get the factorial there. So your answer is supposed to be 10, if I'm not mistaken. I think that is supposed to be it. It's supposed to be 10 factorial. Let us double check, guys. Can we double check? But I think it's correct. 5 multiplied by 4 divided by 2 factorial. So that is going to be 10, and then we have x to the power of 3. There we go. Because if we say 5 minus 2, that is the power of x minus 3, a power of 3, and then we have h to the power of 2. Now let's go to this term here, the last term, which is the fourth one. So also on your calculator, you have to do the following. You have to say 5, and then open bracket, 5 minus 1, close bracket, then you say 5 minus 2, and then close bracket, and then all this is divided by 3 factorial. Don't forget how to press factorial on your calculator. So it's shift, then you press the button that is as x to the power of negative 1. All right, so the answer here as well is gonna be 10. There we go. And then this is gonna be 10 x, then let's say 5 minus 2, and 5 minus 3 is gonna be 2x, and then we know that this is gonna be h to the power of 3. Guys, I know this can be complicated, but if you use your calculator very well here, you must be able to get 5, 10, and 10, and also these powers here. All right, so this is actually x. Remember, let me highlight with 0. This is actually x plus h to the power of 5. But remember, f of x is basically not that. It means that now if you want, let me just open a space here, guys. Try to be quick. I'll try to be as quick as possible, guys, because this can take long. So remember, f of x plus h, f of x plus h is -7. So if you can say -7, then you open the bracket and you put everything in there. Remember, this is x plus h to the power 5. So you're going to have x to the power 5 plus 5x 4 and to the power 4, and then you have h, and then you have plus 10, and then you have x to the power of 3 and h to the power of 2 plus 10 and x squared and h to the power of 3, and that is that. Don't forget, now we have this -3. So in order for you to do it very well, let's just substitute. Let's just finish up here. So we have f of x plus h. Now we multiply by -7 throughout, so this is going to be -7, and then we have x to the power of 5, and then we minus again. Remember, this is -7. So what is 7 multiplied by 5? That is going to give us 35. So -35 x to the power of 4h. And then what is -7 multiplied by 10 is going to be -70 x to the power of 3, and just do 3 here. Okay, let's see, does it look okay? I don't think so. Let me erase this, guys. Let's do the right thing. To the power of 3, there we go. And then we have h to the power of 2, and then we also have -7 multiplied by 10. This is going to be -10, and then we have x squared multiplied by h cubed minus 3. Remember, this 3 is outside the bracket, so this -7 is not going to multiply with that 3. So when you look at this, guys, this is your f of x plus h. The whole of this here is f of x plus h. So this here, guys, is what we have. So this f of x plus h, we have to substitute it here on this formula here, guys. So on our left hand side, that's where we're gonna substitute this f of x plus h there. So let's continue, guys. Let's do it. So do not forget there. Let's we say prime, right? F of x plus h, and then we say limit, and h approaches 0. Remember, write this as long as we haven't substituted yet. So let's continue. So what do we have here? Let me just draw a line here. It's gonna be a bit long line, guys. Okay, it's gonna be a bit long line. I think this is enough. So all this will represent f of x plus h. All this one that I underlined with the red line is supposed to represent f of x plus h. So we're gonna substitute it here. So what is it? We have negative. Let me just be negative. Okay, 7 x to the power of 5, and then minus -35 x to the power of 4 multiplied by h, and then we're gonna have -70, and then we have x to the power of 3 to the power, and h to the power of 2, and then we have another negative to the, oh, I forgot here, guys. This was supposed to be 70. Yes, 70, and then we have minus 70 x to the power of 2, and then we know that this h to the power of 3, and then let's not forget this is minus 3. Now, guys, this is f of x plus h, the whole of this. Now we need to substitute f of x. So what is our f of x? If you can let me just adjust this very well. If you can adjust here, you can see that f of x, I will underline it with this color here. F of x, here's our f of x here, guys. Do you guys see it? So meaning we have to substitute it here. So meaning we're gonna have to substitute it there. So we have to be very careful, because there is a subtraction sign there. So do not forget, first of all, you write the subtraction sign that you see there, and then open bracket, then you write f of x inside the bracket. So our f of x is minus 7x to the power of 5, and then minus 3, and then you close the bracket. Remember, this negative is supposed to affect everything that is inside the bracket. Now we have divide by h. This is where a lot of people make mistakes, so I hope you are paying attention when we introduce the bracket there. Right, so we have to continue. Now I assume that you can understand how we got there. So let me just create a little bit of space here. Right, now let's say f of x. Now we continue f of x prime, and then we say limit, and then h approaches 0. Remember, you continue right this as long as you have been substituted. So let's draw our line there. Let's stop here. Okay, now unfortunately for f of x plus h, we have to rewrite it as it is because nothing is being affected here, only the one inside the bracket is going to be affected. So let's write negative 7, then x to the power of 5 minus 35, and then we have x to the power of 4 multiplied by h minus 70 x to the power of 3, and then h squared minus 70 again, and x to the power of 2, and h to the power of 3 minus 3, and then remember, now it's time for us to remove the brackets. As you can see, we have a negative here, so we will multiply by the negative. This becomes positive because we have negative 1 multiplied by negative 7 to the power of 5 to negative 7 multiplied by x to the power of 5, so this is going to be positive 7x to the power of 5, and then the negative multiplied by negative 3 is going to be positive 3, and then all this is divided by h. So when it's like this, if you haven't watched my videos on how to use this equation, I repeat, go to the icon on top there because I explain all this a little bit better. So but when it's like this, remember guys that you have like terms, and those like terms, they have to subtract each other, and those like terms that you have, they should not have h in them. So meaning that whatever the like terms that you have, there must be no h there. For example, let's look at the first term here. We have negative 7x to the power of 5. It doesn't have h, it's just only x. So this one must have its own like term. If you go further and you look at let's say it's this one here, you go further and the last two term, you have positive 7 x to the power of 5, which is the like term of the first one there. So this one is positive and the first one is negative, so they're gonna subtract each other and they're gonna give you 0. Now you continue. The second term has h, as you can see there. The third term has h squared, and then the fourth term also has the h cubed, so there is no like term for it. But the fourth term, which is 3, it's having negative 3. So negative 3 and positive 3, what do? They subtract each other. So what is it that you're going to be left with? If you did the right thing, guys, here, whatever you're going to be left with on the numerator is going to be what is it? It's going to be I'm running out of words, guys. It's gonna be a term that has h in them. Yes, it's gonna be a term that has h in it. So let's rewrite f of x prime limit, and then we say h approaches 0. So this is gonna be, let's draw our line again. This time around, we are left with negative 35 x to the power of 4h, and then we left with another 70 x to the power of 3h squared, and we are left with 70 x to the power x squared and h to the power of 3. As you can see, we are only left with 1, 2, 3. We are left with 3 terms, and all these are divided by h. As you can see, these terms here, they have h in them, meaning now they are multiplied by h. So it should be like that. You should be left with a term or with terms that has h in them. So as you can see, the first term is h to the power of 1, the second term h to the power of 2, and the third term is h to the power of 3. So they are all fine. So what's the next step? The next step is to take out the common factor. So let me just continue. Now let's do it. Remember, f of x prime. Prime basically means that we are differentiating, guys. Do not forget that limit and h approaches 0. So let's do that. Oh, let's see if your line is going to be fine. Oh, thank you. And then here's what you're going to do. We take out the common factor. So as you can see, the first term is h, the second term is h. So the common factor here is going to be h. And then what are we going to be left with? We'll be left with negative 35 x to the power of 4. Remember, we had only one h, so we are fine. And then minus 70, and then we have x to the power of 3h. And then because we have 2, so we took out 1, we have 1h there. And then we're left with another 70 x to the power of 2h squared. And then that's it. That's it. So when we continue, this is what you're going to have, divide by h. You guys see? Hope you guys can see. So if we take out the common factor, which is h there, so we can say h divided by h, and then the answer is gonna be 1. So what are we gonna left with there? We're gonna left with, let me just do this, f of x prime. Now when it's like this, you get rid of limit and 0, because now wherever there is h, you substitute with 0. So the first term, as you can see, we left with 35, and then negative 35 x to the power of 4. And then the second term we left with 70, negative 70 x to the power of 3. And then what do we have here? We have h, but we substitute that h with 0 because h is approaching 0. And the second and the last term is going to be 70, and then we have x squared. But what do we have there? We have h, which is going to be 0 because h is approaching 0 squared. All right, so this is what we have. So as you can see, these terms here, they will give you let's just do it. This last two terms, the first term is going to give you 5x to the power of 4, and this one is zeros because they are multiplied by this 0, and this one also multiplied by 0. So this is gonna be our answer, guys. I know this is very long, but trust you me, this is not long. There are other problems that are longer than this, so I'm hoping that you manage to understand, guys. If it so happened that you didn't understand, you can rewatch this video until you understand. Do not forget, guys, as you can see that expression there, we were supposed to differentiate using the first principle. So don't forget, you're supposed to use the formula, and then do not expand it to the fifth term. There's no need for that. Expand it to the fourth term, and that is enough. You get the very same answer that we got there, which is negative 35 to the power of 4. Then guys, if you like what I just showed you, don't forget to like the videos and subscribe to the channel if you haven't, and share these videos to your friends, just in case if they are doing the same subject as you are doing. And at the end of this video, there will be a playlist. If you want to watch their videos in a sequence order, there will be that playlist. You can click on that playlist and watch those videos so that you can understand much better. But other than that, guys, please do not forget to comment if it so happened that you didn't understand or it is a better way of doing this. Thank you very much, guys, for watching. Till next time, cheers.